Hello and welcome back to another video. So in today's video we're going to be covering prime factorizations. And what is a prime factorization? Well, any single number you pick can be broken down into primes, multiples of primes, right? Or the product of primes. So if we pick a number, let's say 20 here, we can break 20 down into 2 times 10, which we can then break down into 2 times 2 times 5. All of these numbers are prime, and that is the prime factorization of 20. This is really helpful when you're trying to figure out square roots, or whenever you're doing least common multiples, greatest common divisors. And one example, let's do like the square root of 20. We can see that this is going to be equal to the square root of 2 squared times 5. And now because there's 2 of these 2's, we can pull that out. So this is the same as saying the square root of 4 times the square root of 5. And since this is equal to 2, we can write this as 2 square root 5. And that's one of the many examples of why prime factorization is important. One of the methods that you will first encounter is the factorization tree. So you would pick a number, let's say 38, and you would just break it down here. So we would split it into 2 different branches. And so we know that 38 is an even number, so it's going to be divisible by 2. And you can go ahead and do a little division real quick if you need to. And the other one is 19. So this breaks down into 2 and 19. 19 is a prime number. So it's done. So you get 2 and 19. So 38 would be equal to 2 times 19, which we know is true, and both of these are also prime. Let's pick another number. Instead of 38, let's pick 39. So 39 is a multiple of 3. And there is an easy way of checking if it's a multiple of 3. I think you add these, and then if that's divisible by 3, you know that you can divide by 3. So 3 plus 9 is 12. 12 is divisible by 3. So let's go ahead and put a 3. And this would be 3 times 13. And so 13 is prime, and 3 is prime. So again, we see that we already have our prime factorizations there. So it'd be 3 times 13. Let's try to pick a number which we know is going to break down into many different numbers, right? Instead of just 2. And let's go ahead and pick, I don't know, 36. And there's different ways of breaking this down as well. So we could, if we wanted to, break this into 6 and 6 and then break those. Or we could break it into 4 and 9, or whatever. It doesn't really matter what you break it down to, because your primes at the end will still be the same. And let's go ahead and show you guys 2 different examples of that. So 36, let's do 6. Let's do 6 and 6. And then each of these is going to break down, into 2. I'm struggling here with changing the colors. Okay. So then each of these are going to break down into 2 and 3, because 2 times 3 is equal to 6. And same thing over here. 2 and 3. So we would grab all the numbers at the end of the branches. So 2, 3, 2, 3, all of these right here. So we know that 36 is equal to 2 times 2 times 3 times 3. And when you have multiples, we're just going to make these into exponents. So 36 is equal to 2 squared times 3 squared. Now let's go ahead and do 36, but use different numbers here. So 36. So we can break this down, and let's pull out that 2 first. We see it's even, so let's go ahead and do that. So that would be 2 and 18, which would be 2 and 9, which would be 3 and 3. So here, we grab all the numbers at the end of the branches, and those would be our prime factors. Our prime factors of 36. And again, we get 2 times 3, or 2 times 2 times 3 times 3. So 2 squared times 3 squared. Knowing your prime factorizations is also really helpful for reducing fractions, as you can see immediately what they have in common and then cancel those out. And so if we did 20 over 36, we saw earlier that 20 was equal to 2 times 2 times 5. And we saw earlier that 36 was equal to 2 times 2 times 3 times 3. And so we can go ahead and cancel out what they have in common. So we can cancel this 2 and this 2, and then this 2 and this 2. And so 20 over 36 would also be equal to 5 over 9. Another way that you can do that is just by dividing these out. So 20 divided by 2 is 10, 36 divided by 2 is 18, and then divide again. So 10 divided by 2 is 5, and 18 divided by 2 is 9. But that's the same thing as what we did here. And so it's really helpful in many different situations, such as, making a fraction more simple, simplifying a fraction. And that is a quick introduction to prime factorizations. I hope you guys learned something valuable in this video, and I hope that it actually helped you guys. I know that whenever you get into a little bit of higher math, it's really helpful knowing these little tricks because it can save you quite a bit of time. And especially looking at 20 and knowing that this is 2 times 2 times 5, just off of the cusp. And so by doing that, you can then see, oh, this is also a multiple of 2. I can cancel those out, and you can kind of start to see what 20 over 36 might look like. Anyways, that's all I have for you guys today. I hope you enjoyed the video, and have a great day.